Number 3 asks, how many different passwords can we make only using the letters EVA followed by the numbers 1982? So this is another example of a permutation, and an arrangement where order matters, because if I said, well, what's one possible password, maybe we say Eva 1982, right? But maybe we switch it around and we say 1982 Eva, right? So those would be two different passwords because the computer interprets the order of the characters there, so order makes a difference. And then, we could sit here and just try to say, well, what if I switched around the letters and I switched around the numbers? But this isn't a very efficient way of solving this, to figure out how many different passwords we could make up, because we would be here all day. So we want a more efficient way of doing this, and so we go back to this idea of decisions. How many different decisions do we have? So I got the first character in the password, the second character, and the third character. So there's possibilities here that this is going to be a letter, and a letter. And then I say, well, how many different letters do I choose from? Well, I'm not picking from the whole alphabet here, because we're restricting it just to those 3 letters right there. So there's 3 letters that could go in this spot. And then once I've selected one of those letters, doesn't matter really which one it is, now we're going to use one less, right? So now there's only 2 letters to pick from. And then once I've used another letter, now I only have 1 less to pick from, right? And we're making the assumption here that we're using each one of those letters once. Or at least, I don't know if that's clear from how the problem's worded, but that's the assumption we're making, is that we're using each one of those characters just one time. So now we've got our 3 letters down, so now we've got, what's the other thing we got to look at? Well, then we've got 4 different numbers that we're choosing from. So this is going to be, I've got 4 numbers that I'm using. And let's get this out of the way. So 4 different numbers that I'm using. Again, I'm not choosing from all numbers. I'm just picking from the 4 numbers that I want to use here, 1982, maybe somebody's birthday. So I've got 4 numbers to pick from. And then once I've used one of those numbers, now I have 1 less, and 1 less. Technical difficulties here. There we go. And then I've got 2, and then I've got 1. Right? So same idea is that now that I know that I've got 3 letters to pick from, and I've got 4 numbers. And by the way, when you do this, we can just kind of do some shorthand here too. You don't have to write out the word numbers, so maybe we just say this. But it is good to label what it is that we're describing with each one of those numbers. So same idea. We're just going to multiply all those things together. 3 times 2 times 1 times 4 times 3 times 2 times 1. So we get that there's 144 different passwords that we could create. Now, you noticed on this one that there was a little bit more that we had to type in to the calculator. So then it was like, well, what if I was picking from 26 different letters and 10 different numbers, right, if it was much larger. So there's a shorthand way that we write this, and it's what's referred to as a factorial. So instead of writing 3 times 2 times 1, I could write this. The symbol that we use, it's the exclamation point. What it means is it means that number multiplied all the way down to 1. And 4 factorial, or 4 times 3 times 2 times 1, could be written as 4 factorial. So this is just kind of a shortcut or shorthand way of writing it. You noticed on these other problems, the one before this, I didn't use a factorial on this one because it didn't count all the way down to 1. It just was 10, 9, and then it stopped at 8 because we had more people competing for only a few spots. We weren't, not everyone received a medal in the context of that problem. Whereas here, every letter got used of the 3, and then every number got used of the 4. So as a shortcut, instead of doing what we see there, 3 times 2 times 1 times 4 times 3 times 2 times 1, the shortcut is, if you, at least on this calculator, if you go to Math and then PRB, and then you see the 4th thing down, that's the factorial button, right? So what I could type is I could type 3 factorial and then 4 factorial. and we get the same answer, 144. If you're using your own calculator, if you look somewhere on the scientific calculator, you'll find a button that probably says X with an exclamation point. That's the factorial button. So either way works. It's just I think you'll find that when the numbers get a little bit larger, that it's going to be a little bit easier to type it in with the factorials, right? But on the next problem, we'll kind of look a little bit more at factorials. All right, so that finishes up number 3. So try number 3 on the right, and then we'll move on to number 4.